Hello everyone. Today we are going to start our next lesson, elastic limit. So what is elastic limit? Elastic limit is basically the property of the solid, and why we study. I have already told you that we have to understand the physical nature, the physical property, the physical characteristic of substances in order to construct various designs, various engineering designs, or in order to construct various products in various industrialized products. Okay, so an elastic limit is basically the maximum stress within which the body regains its original size and shape after the removal of the deforming force. So whenever we apply any force on the object, okay, the more quickly the object regains its original size and shape, we call this as the elastic limit, and the property is called the elasticity, and we call that object as the elastic property, as the elastic element or the elastic object. If the deforming force exceeds the elastic limit, the body acquires a permanent deformation. For example, rubber band loses its elasticity if we pull it apart too much. It changes its size and becomes misfit to be used again. Is that clear? When beyond this limit, whenever you apply further force, the object will lose its original size and shape. Now, what is Hooke's law in elastic limit? You have learned in your previous classes Hooke's law, that Hooke's law is basically the force has direct the relation with the displacement of the object. Okay, it can simply say that for a small deformation within the elastic limit, the strain produced in a body is directly proportional to the stress that produces in it. So whenever you apply stress on the object will produce a strain, and that strain depends on the stress. So we can say that strain produced within the object is directly related to the stress, putting the value k as a constant, and this k is known as the proportionality constant or proportionality limit, and is known as the modulus of the elasticity. Hooke's law is an empirical law and is found to be valid for most materials. Empirical law means practical law, means Hooke's law is valid, it is practical for most of the substances. But however, there are some materials that do not obey Hooke's law, that do not obey this equation. Okay, so overall, generally, stress is directly proportional to strain, and provided the elastic limit. Okay, so you can see this is a graphical representation of the Hooke's law, that when we apply stress, strain will produce. Okay, and you can see a straight line graph showing the direct relationship between the stress and the strain. Now, stress strain profile curve. The curve shows the it is a very famous curve, and it shows the relation between the stress and strain. Now let me describe you this curve. Whenever we apply a stress, okay, whenever you apply stress on the object, strain produce. Okay, and till point A, Hooke's law is valid. Mean to say that the stress is directly proportional to strain. On further applying the stress, the strain will be no more directly proportional to stress, but the body will regain its original shape. Okay, so up to point OA, we can say this region is the elastic limit region, means that the Hooke's law is applicable, is valid up to here. After point A, Hooke's law is not valid. but till point B the body can regain its original shape. Okay, so from here up to point O B, from point O to point B, we can say this is the proportional limit. Okay, sorry, elastic limit, but up to point OA there is proportional limit, means Hooke's law is valid. After point A, elastic, there is the Hooke's law is not more valid, and so we call this as the elastic limit. On further applying the stress, the body will further strain will produce in the body, and after point B the body will no more regain its original size and shape. Okay, so and then if you apply further stress, further force on the object, the point D will reach, which we call that you have applied the maximum stress, or we can say that the maximum stress is applied on the object. And if you apply a little bit further stress on the object, a point will reach, which is point E, that the object will break down. Okay, the object will break down, or we can say that the object will rupture. Okay, keep in mind that from point B up to point E, these 4 points shows the plastic behavior of the object. Plastic behavior means that applying stress, there is strain is producing, further strain is producing, and from point okay, and keep in mind that if the point D and E are very close to each other, we call that the substance is brittle. Brittle means that it can break very easily. Okay, like for example glass. Okay, or any other substance. But if the point D and E are very far apart, they are not very close, they are very far apart, we can say that the object is very ductile. For example, metals are very ductile. You can change its shape into different forms, you can curve it, you can bend it, but it will not break. Okay, you cannot break metal very easily. Why? Because the metals, the point D and E, they are very far apart. Is that clear? So here from point B up to point E is the plastic behavior, showing the plastic behavior of the point of the material, sorry, and from point O up to point A is showing the proportional limit, showing the shows that the Hooke's law is valid, and from point O to B shows the elastic limit. Elastic limit means that the body can regain its original shape on applying the further stress. So I hope that you have understood this stress strain profile. It is very important from physics point of view, and again I would like to tell you that different materials have different stress strain profile depending on this portion and on this portion. AB point and DE, these 2 points are very important. Again, this is the permanent set. Okay, elastic behavior up to point B shows the elastic behavior, and then the plastic behavior starts from the point B up to point E, and then you can say after point E the fracture point reaches and the the object break down. So I hope that you have understood the lecture and enjoy your studies and have a nice time. Goodbye.